Hello everyone, we'll start the session for today. So last class we were going through the topic multithreading and we had covered a few topics already on multithreading, like we had gone through introduction to multithreading and how we can basically create and execute the threads. So there were two basic methods of creating the threads. One was like extending the thread class and another was by implementing the implementing the runnable interface. And when you extend the thread class or implement the runnable interface, you have to provide the implementation of the run method. So run method is the method where you have to basically write the code where you want to implement multithreading, and in that particular run method you write the logic. And we had also seen the thread life cycle and the states of different and the states of thread in the life cycle. So we had gone through the life cycle, like when a thread is newly created, so it's in the new state, and for a thread to process any step or process any step of the program, it has to come in the runnable state. And once the thread comes in the runnable state, then it can go to the running state. And from the running state, we can either make the thread to wait, or we can like make the thread to sleep. So wait and sleep are basically the states where a thread is like made to pause for some time, and then a thread can also be terminated, so we call that state as the dead state. So these were the basic states of a thread in the life cycle of the thread. So most important is the runnable state. So for a thread to start working, it has to, for a thread to start the processing, it has to come in the runnable state. That is a must condition, and only then it can go to the running state. So running state is actually when the thread starts processing that step, or like processing the each step of a program. So these are the important states of a thread, and these are like uh, maintained by the thread scheduler. So thread scheduler has like a different m- uh, so scheduler will be basically scheduling the thread to perform these activities. So we'll see the different states as well. So we will see like how we can maintain inter-thread communication or synchronization. So few topics were like left in thread handling and multi-threading, so we'll go over those. So in thread scheduling, so the thread scheduler is kind of a mechanism where like the thread scheduler will schedule the thread, whether the thread has to basically stop or pause, or it has to like process. So it's the work of the thread scheduler. And there's a sleep method in thread scheduling. So if you want to process your program, and if you want to like if you want to like pause the logic, or if you want to like pause the program for some period of time, then you can like use the sleep method. We'll see how we can like basically implement the sleep method. So we had gone through this program already, uh, right, where we were able to like create two threads, thread 1 and thread 2, and then we were starting the threads. So start when we start the threads, it basically starts executing the run method. So we had seen this program, and we had seen the program where we had extended the thread class, and we had also seen the program where we had implemented the runnable interface. In both the scenarios, you had basically implemented the run method, and then you had created two threads, and then once you start the threads, so it comes in the so the run method starts executing. So see, when you create the thread, it is in the new state. When you create the thread, suppose you write down like thread t1 equal to new thread, and you pass the object reference of the runnable interface. So this is said to be like the thread is created in the new state. And when you do this t1 dot start, so t1 dot start basically uh, uh, so when you do this thread t1 equal to new thread, it's the thread is created and it goes to the runnable state. So runnable state means the thread is now ready. The thread is basically ready and it can start the processing. So once you do this t1 dot state, it goes from the runnable state to the running state, and in the running state it starts executing this run method. So we had seen the program where we were able to print numbers from 1 to 10, and this thread dot current thread dot get name basically gives you the thread name. So when we had created two threads, we had given the names thread 1 and thread 2 respectively. So which thread is currently performing the job, that can be printed by this thread dot current thread dot get name. So let's try to print this once more, and then we'll like modify this program. Okay, so this is the output. See, it's printing the numbers 1 2 3 4 5 6 7 8 9 10, and then we are printing like run by thread 2 or thread 1, means which thread is currently printing this, that is like thread 2 and then thread 1. So this is the program which we had already seen. So let's run it once more. So when I run this program, just observe the output. Everything is printed all at once. Just observe the output. Everything is printed all at once. Now what I want to do, I want to, means there can be certain scenarios where you want to like stop your program or stop your logic and then start the and then print. So what I can basically do, in this run method, I can ask the thread scheduler to pause for some time. And how we can do this? We can basically call the sleep method. So thread has a method. That method is basically called sleep method. So I'll call that sleep method. And if you see this sleep method, it takes time. So we have to provide arguments, that is in milliseconds. So if I provide like 1000 milliseconds, that is like equivalent to 1 second. So we want that after printing this statement, it pauses for 1 second before printing again. And see this, we are getting some error at line number 8. So what error we are getting is, we are getting an exception. So we need to handle this exception. And see, it's giving, the editor is giving us suggestion that you need to surround it with try catch. So let's click on this. So this piece of code, whenever you write this thread dot sleep, there are chances that there can be like interrupted exception. So there are chances that there can be interrupted exception. So this is an exception which you will see while performing most of the uh, thread activities. So at that time, we need to put this particular statement thread dot sleep in the try block, and this in this catch block, what type of exception we are expecting. This is interrupted exception. So now the question comes like how you will get to know like we can expect interrupted exception. So this comes by like practice, and you have to like understand this concept that whenever we are going into the life cycle of a thread, or we are trying to like wait on a thread or trying to pause a thread, so there are chances that you may get an interrupted exception. So interrupt is basically a kind of pause or a kind of waiting state that the thread goes from runnable state to like waiting state or sleeping state. So at that particular time there are chances that an interrupted exception is can occur. So we have to basically catch this type of exception. Now now let's try to run this program again, and you need to like observe the output. Just try to focus on the output. Once I run this program, see the output. It's taking a pause right after printing this. It's taking some pause. It's taking a pause of 1 second and then printing the next output. Were you able to observe, everyone? Let me try to run this again. Just observe the output. It's taking some time, right? Everyone is able to see the difference. So this is basically the function of the sleep method of thread. So when you want to ask the thread scheduler to provide some kind of like pause for some duration, then what you can do, you can ask the thread scheduler to go to sleep, and that is why the current thread which is executing will go to sleep. Means suppose you have like two threads, thread 1 and thread 2, and thread 1 and thread 2 are basically trying to print this loop where we are trying to print from number 1 to 10. So at that particular time, if you want to provide some kind of like pause, so you can ask the thread scheduler to wait for like 1 second. If you want to like wait for 2 seconds, we can like provide 2000 milliseconds. So that is upon you. So in such a case, you provide the duration thread.sleep, and you provide the duration in milliseconds, and you have to surround this piece of logic in this try catch block, and the type of exception that you may expect is interrupted exception. So we had already seen how to use exception handling uh, and where to use. So whenever there is a chance that your program can create an error or create an exception, so you surround that piece of code in your try block, and then you when you use your try block, you have to use the catch block, and in the catch block you try to like handle the exception. So in the catch block, you basically pass the type of exception that you may expect. In this case, it is like interrupted exception. So we'll pass the class reference here in the catch block, and then we'll try to print out the logic. We'll try to print out the number that we want to print. So this is basically the difference when you use thread.sleep. It's basically taking some pause before printing. So the threads are basically going to sleep for a second and then performing that task. So this is the use of the sleep method. Okay, let's go to another slide. So now there is like thread scheduler and prior. Okay. So guess so there are some times when you want to, like, suppose there is some asynchronous call, or suppose you are calling one API, and that API takes some time, and then you have some piece of code written below that, and what you want to do is basically you want that particular API response to come first, and then you want to start resuming your work. So at that particular time, what you want to do is, like, you can ask the thread to uh, go to sleep. So once that asynchronous program, like, gives you the output, then that particular you have that particular output, and then you start, like, resuming your work. So by asynchronous program and all, it's like a bit advanced topic, but what I want you to understand is, like, asynchronous is basically if you call something like in an asynchronous API, so at that time you just call that API and proceed forward. You don't wait for the output. So that is the case of asynchronous uh, API. But what happens when you, like, when you call the asynchronous API and you want that job gets finished, and then you start performing your next job. So you have already called the asynchronous API and you want that to get finished. So what you can do, you can ask the current thread to go to sleep for some particular time, and then once that asynchronous job has completed its processing, your job can be resumed. This is like one scenario where you can use sleep method. Is it clear, Gasa? Okay. Now, now the thread scheduler can perform some kind of, like, priorities. So what I mean by priorities is, if you want one of the threads to be given more priority or one of the threads to be given less priority, there are, like, methods. So what you can just do, you can go over and set the priority. So there are, like, methods like set priority, and there is a value of 1 to 10. By default, if you do not set your priority, so this there is a default priority of 5. So 1 is basically the least priority, and 10 is basically the highest priority. So see, every Java thread has a priority that helps the operating system determine the order in which threads are scheduled. Java thread priorities are in the range between min priority, a constant of 1, and max priority, a constant of 10. By default, every thread is given priority. Norm Normal priority is a constant of 5. Threads with higher priority are more important to a program, and threads should be allocated processor time before lower priority threads. However, thread priorities cannot guarantee the order in which threads execute, and very much platform dependent. See, what we have seen is we do not have the control about the order of printing of this. Sometimes you might see that thread 2 is printing something, and sometimes thread 1 is printing. So how this is happening behind the scenes, the thread scheduler is allocating some processor CPU, means how everything works in the background. It's like there is some process going on, and that process basically requires some CPU, right? That process basically requires some CPU. So it is the job of the thread scheduler to give that particular CPU to that thread. And what you want to do now, you want to, like, prioritize some thread. Let's say this T1 thread, I want to, like, prioritize this thread. So let's say I do some kind of, like, t1 dot set priority thread dot, let's say, max priority. So I want to prioritize the T1 thread. So in this particular time, okay, let's start the thread and then prioritize this thread. So I want to suppose the thread T1 is of more priority to us. So I want to give it like the maximum priority. But still, this does not guarantee the order of execution of this program. This does not guarantee the order of the execution. Means it is the job of the thread scheduler that it will provide. But if there is a chance of like thread starvation, so thread starvation is like that thread was not getting the CPU or the processing power from the operating system, and the thread terminated or died. So in order to like solve that problem, what you can do, you can set the priority of the thread to max priority. Suppose this T1 thread, this must get the CPU before any thread because this is of max priority. So let's try to run the program. See, you will still see the order of output can still be like different because both the threads are getting the CPU, but thread T1 is still getting like maximum priority. So you can set it on your own, like which thread you want to prioritize. So you can set thread T1 dot set priority. You can also set like, let's say I want to set T2 to minimum priority. Let's say T2 is of minimum priority. So you can do T2 dot set priority thread dot min priority. And this min priority, if you hover over it, it has a static value, like a final value of 1. So you cannot modify this value. So this is of priority 1. And if you do a max priority, this is of value 10. You can also like just remove this and give a value between 1 to 10. Let's say you want to like give 7. That is also possible. So this is like prioritizing the threads, and this you can do basically by setting the priority. And priorities are basically like max priority, min priority. If you do not set the priority, then there is a normal priority. That normal priority that has a value of 5. So this is about like thread scheduling and priority. So behind the scenes, the thread scheduler takes the job of like allocating CPU or processing power to the threads. And if you want to like prioritize any thread, so you have to inform the thread scheduler that this thread has the maximum priority. If there is any CPU crunch, then please provide this thread the CPU first so that it can perform the job. So you can do it by T1 dot set priority or T2 dot set priority, and then you can like pass the maximum priority or minimum priority values. Okay. Okay. Now let's go to another topic, and this topic is like very important. This is about like thread synchronization. So I talked about one of the scenarios, right, where two people are trying to access the bank account. This scenario we discussed in the last class. So if two people are having access to the same bank account, and what they are trying to do, they are trying to withdraw the money. Let's say there are like $1,000 in the bank account, and one person went to the bank to withdraw the amount, and one person went to the ATM machine to withdraw the amount. So if they do the same transaction, if they are trying to do the same transaction at the exact same moment, what can happen? Let's say one of the persons already withdraw the $1,000. So the other person is also trying to like withdraw the $1,000, but there are only $1,000 in my account. Only one of them can withdraw, right? Now, if the threads are not synchronized, then what will happen? Like one person has already withdrawn the amount, but it is not reflecting to the other person, and the other person is like having no idea why he's not able to withdraw the amount. So that can cause a failure to the system, right? Because all the threads are trying to do the same operation, but what happens that that can lead to like an inconsistent state, right? Because you only have a balance of $1,000 and two threads are trying to withdraw the same amount. They are trying to withdraw the entire amount. You're getting the scenario, right? So in that case, what we want to do, we want one of the threads to complete the operation and then the other thread to try the operation. So at the time, if one of the threads has already withdrawn the amount, that amount is like reflected zero to the next thread once that thread tries to withdraw the amount. So that thread understands that, okay, now this amount is already withdrawn, there is a balance of zero. So this is like this is like locking of a resource. So by resource I mean that uh, there is a type of operation that I'm trying to perform, and I want one of the threads to complete the processing, and then I want the other thread to resume the work. So just see this diagram. This is like teller 1, teller 2, and teller 1 is telling wait until I am finished. So this is like there is some file cabinet that teller 1 is using, and teller 2 also wants to use the same file cabinet. Let's say this file cabinet is kind of a resource. So teller 1 tells that let me just finish my work first and then you can resume. So this is like synchronizing or locking an object. This is synchronization. This diagram basically shows you synchronization, that once one of these threads has performed its task, then the other thread comes to picture. Other thread comes to picture. So in that case, what happens? The threads are basically operating in a consistent state. They are not messing up with the activities of the other thread. Let's say means one of the threads is like performing its job. We do not want the other thread to go and mess up with what work is being already done. So in that case, what can happen? It can lead to like inconsistent state. So we do not want that kind of scenario. So we perform thread synchronization. So thread synchronization is like very important, and sometimes you might also get some interview questions on thread synchronization, like what is the way that you would use to synchronize the work, or like how do you like provide synchronization to the APIs that you use. So we'll see like how you can do that in through the code. So just see this diagram. Synchronization is basically acquiring object locks between interleaved execution of multiple threads. So see this diagram. There are like there are three threads, thread 1, thread 2 and thread 3. And this is the same example of the balance in the bank account. Let's say the balance is like $5,000 and there is a deposit amount. And what you want to do when you deposit the amount, you want only one of the threads to perform the operation. So what you will do in that scenario, let's say thread 1 wants to deposit that amount, and at that exact moment you don't want any other threads to perform the deposit. Even if they suppose they are still doing that deposit, they are still doing that deposit, but what will happen, thread 1's job will be first completed, and then those threads, suppose thread 2 and thread 3 are also depositing, so only after thread 1 has completed the job of depositing, its job is done, the amount is deposited to the bank account, then thread two's work will start. So this is like creating a lock over that particular process. Let's say there is an API for deposit. So in this case, what is happening is thread 1 has created a lock, and this is basically called an object lock. You're understanding the scenario, right? There are three threads, and all the three threads are trying to deposit some amount in the bank account. But let's say like all the three threads have uh, hit the deposit button or something like that. So what happens in that case? Since thread 1 has the object lock, so first thread 1's deposit API will be completed, and once the balance is like updated, then thread 2's API will work. That only then thread 2 will be coming to picture, that it will deposit the amount. So this is basically doing the job in a synchronized manner so that the deposit functionality does not messes up. So this is the role of synchronization using threads. So changes made by one thread will be guaranteed to reflect to the another thread. So see, if all three threads like deposit like $1,000 at the same time, so what if there is no synchronization, then what will happen? The other two threads can just see the amount as like 5,000 plus $1,000, that is like 6,000. But when we like synchronize the process, right? So first thread 1 has completed the deposit amount and it's updated, it's 6,000. Now let's say thread 2 acquires the object and tries to perform the operation. So thread 2 will basically see the updated thing. Thread 2 will basically see the updated amount, and thread 2 will see the amount like $6,000. It again makes a deposit. The amount gets updated like 7,000, and thread 2's job is done. Then thread 3 acquires this object lock. Means thread 3 has the thread 3 comes into the picture and deposits that particular amount, and then the amount is reflecting like 7,000 plus 1,000, and that is basically like 8,000. So this is like to make sure that if there are like multiple threads performing a job, so the job completed by the first thread is like visible to the other thread. Means whatever changes were done by thread 1, that particular updated amount or that particular updated data is visible to the other threads. So this is why synchronization of APIs is required in Java. Did you understand the scenario? Anyone has any issues in understanding the scenario? Okay. See, we'll see how basically we can perform the thread synchronization. Okay, let's let's go to our IDE. So Java has made this synchronization of APIs easy, and that's like basically just using one of the synchronized method or using a synchronized block. So whatever piece of code you want to uh, synchronize, you can provide a synchronized uh, you can use the keyword synchronized in your method implementation, or you can provide it a synchronized block. Let me create a package and let me name this. package as synchronize. Okay, let's create one account, and let's say in this account we basically have the account number. Let's say we have the name of the person, and let's say we have some balance in this particular account. Let's go ahead and create a parameterized constructor. Okay, and let's try to write one API to or a method to get the balance. Let's write a method to get the balance. Public float get balance, and this get balance method is basically used to return your balance. Let's say I want to return the balance. So now what we'll do is we'll try to deposit some amount. So we'll try to deposit some amount. So in that case, what we want to do, we want to set the balance. So when you deposit any amount, you are basically updating the balance, right? You are adding some amount to that particular balance. So let's go ahead and try to create one method where we basically set the balance. So I can do it this way as well. You know the setter methods, right? You know this about the setter methods. So setter methods are basically used to update your data members if you want to provide some new value. So if I just go ahead and generate this setter, I want to like update my balance. So I will just update the balance. So let's say we are creating the set balance, and this is basically uh, updating the balance. So what I will do, I have two methods, like one for fetching the balance and one for updating the balance. Now let's say I am creating one deposit method. So this deposit method will be basically called if the user is trying to make any deposits in the account. So generally we used to write something like this, right? Public void method name deposit, and let's say we want to deposit some amount. So what we'll do is, let's say we want to print out uh, deposited by, let's say we want to see like which thread is like currently working here. So uh, while depositing the amount, let's say deposited by, I want to like see like which thread is currently working. So what I can do, I can do something like thread dot current thread dot get name. We have seen this method already where you can like print the name of the thread. Now what I want to do is I want to get the balance. So we already have a method to get the balance. So let's say we write this as current balance, and then we call our get balance method. And after this, what I want to do is I want to create something like updated balance, and this updated balance is basically your amount plus balance, right? So this balance is basically the actual balance, and this amount is the amount that you are depositing. So once you deposit the amount, so updated balance will be amount deposited now and previous balance. So what you will do, you will again call the set balance method, and you will use this updated balance. So updated balance, once it is set, so what you can do, you can print out the updated balance. So this is a simple method, and I am doing a simple operation of adding some amount to our existing balance. So let's print out this updated balance, and then what we want to do, but this method is still not synchronized. We talked about the chaos that can be created if there are like lot of threads working on this, right? So what can happen is one of the threads is already getting this, executing this get balance and trying to update this. Other thread also comes and tries to do the same thing. So at that particular instant, two threads are like updating the balance, and they are calling this set balance method. So in that particular instance, what can happen, there could be some mess if there is no object locking provided over this method, or if there is no synchronization provided over this method. So Java allows you to synchronize this method such that whatever changes are made by one of the threads is definitely visible to the other thread, and the things remain in a consistent state. Now I'll make some change to this. See, there is something called synchronized. What we can do, we can make our method as synchronized. See, we have just introduced this synchronized keyword over this method implementation. So this is like making this method synchronization. This is like creating a synchronization over this method. So you can do it by using the keyword synchronized, or you can do something like synchronized. Okay, one second. So in this synchronization block, basically what we do is we create some object lock. Means you will have to like create some object lock, and like uh, when you create that particular object lock, what you can do is you can like pass the object reference. So you know that this basically points to your current object, right? When you write this, this basically refers to your current object. We have already talked about this. So what you can do, you can be like put this entire piece of code in this synchronized block. So and you can like comment out this. So this is also like doing the same thing. This is also doing doing the same thing. Either you can like write your code in this way, like you have created one synchronized block, you have passed the current object, and in this is the piece of block like curly braces start and curly braces end, and you write your entire piece of code here. Or what you do, you can just make your method synchronized in this manner. So let's go by the previous approach. I'll remove this piece of code from here and I'll uncomment this one. So this was as easy as this. You just have to make your method synchronized. I'll comment out this so that you at least remember that there is a synchronized block, something like this. Synchronized block of, and what you want to do here is you write some code. So this is synchronization, and what you do is you just make this method as synchronized by writing this synchronized before the void expression. So this way you can basically synchronize your this way you can basically synchronize your deposit method, so that no two threads try to execute the same deposit method or set the balance at the same instant. Now what I will do, I'll create one main method, and in the main method I'll try to create one account object. So let's go ahead and try to create one account object, and when I create the account object, I have to basically pass the account number, name and balance. So what I'll do is, let's say account number is something like this, 1 2 3 4 5, and the second parameter was the name of the person. Let's say John is opening the account, and let's say the initial balance is like $1,000. So we have created one object of the account class, and now what I want to do, I want to I'll create some threads here. Let's try to, okay, let me go ahead and try to create one. I need to extend my thread class as well. So what I will do is I'll create some transaction class, and this transaction class will be basically extending our thread class. And what I'll do is I will take this account object here, and I'll create a parameterized constructor of this transaction class. Generate constructor. Okay, one second. I'll I'll just create the parameterized constructor where we have to pass this account. Okay, one second. Okay, I have initialized this data member account class here, and now what I want to do is I want to implement the run method. Public void run, and what I will do is account dot deposit, and in this deposit method I need to pass some amount. So let's say I have passed this amount. So what I will do now, in the previous class I have our main method. See, this class is doing a transaction, and I want this to be used by multiple threads. So if we want to like use our transaction for by multiple threads, what I want to do, either I want to use like thread implementation by extending the thread class, or by implementing the runnable interface. Because I want to create multiple threads, right? So I will extend the thread. So let's go by the first approach where we are extending the thread, and I am trying to use this account class here. And what I'm doing, I'm taking an object reference of the account class, and I'm trying to create a parameterized constructor of this transaction class. Now I want to perform some deposit on this particular account. So I'm calling the deposit method, and I'm passing the amount which I want to deposit. Now let's go here again. I have created an initial account with this particular account number, with this person's name, and this is our initial balance. Now what I will do, I will create a transaction T1 is equal to new transaction, and I'll pass the account reference. So remember, this transaction class expects one account object, right? So we will pass this object reference here, and let's go ahead and try to create some more transactions. Let's say we name it as like T2, and let's say we name it as T3. And what we'll do, we will try to start these threads. So also you have to do one more thing. You have to like see, you have to ensure that once one of the threads has completed the execution, then the other thread starts. So in that case, what you can do, there is one join method, there's one join method. So you will have to do t1 dot join, t2 dot join, and t3 dot join, and you will get some, you'll have to handle the exception. Now see, I have told you that threads will be basically throwing interrupted exception most of the time, so you will have to handle this. So let's say I go ahead and try to handle this exception by using the interrupted exception. Now let's try to run this program. See what is happening. I'm trying to deposit deposit $200, right? And our initial balance was 1000. Our initial balance was 1000. So what it's doing is current balance is 1000, and I am trying to do it with the help of three threads. See, we have created three threads here, right? And I'm doing t1 dot start, t2 dot start, and t3 dot start. So if I have not synchronized, what can happen? The current balance was 1000 and it was like updated by one of the threads, and while updating other threads can come and fetch the current balance, so that can like lead to a chaos. So that is why see the consistency. Current balance is 1000, updated balance is 1200, and current balance is 1200, updated balance is 1400, because each time we are doing this updation by $200. So 1000 plus 200 is $1200. Then 1200 plus 200 is like $1400. And then this is like 1400 plus 200. This is $1600. And see, we are once, see, one more thing to observe here is thread 0 has completed its operation, and only then thread 2 has resumed. And once thread 2 has completed, only then thread 1 has like started its work. So what is basically happening, one of the threads like completes its work and then the other thread starts the work. So this is the use of join. So join method ensures that one thread waits until the previous thread has completed its execution. So see, I think yeah, are you understanding? So I know that there's like a lot in this program that I've done. So I'll just give a brief summary again. So let's see what we have initially done. So we wanted to create a scenario where we have to deposit some amount in our bank account. So we had some initial balance. So that is why what we did, we created an account class, and that account class has three data members like account number, name of the person, and some initial balance. We created one parameterized constructor to initialize the data members, so that once this object is created, so there is some data to this. Now I have created two methods, getter and setter methods for getting the balance. So this method basically gives you, fetches you the balance, and this method basically helps you update the balance. So see, this dot balance equal to balance. So this method basically helps you to update the balance. And you have your deposit method. This method will be called by the user who wants to deposit some amount, and this amount is taken as a parameter. Whatever amount you want to deposit will be taken as a parameter in this variable. Now what you do, you are trying to deposit, you want to see like which thread is currently working to deposit the amount, because we will be using like multiple threads to perform this operation. So we want to see like which thread is currently working. So you can do that by doing this thread dot current thread dot get name. So we are printing out the thread name, and we are also printing out the current balance. So current balance can be printed by the get balance method. And what you are doing, you are updating the balance. Updating the balance means initial balance plus the amount to be deposited. And what you're doing, you are setting this balance. Now you need to set this balance. So your initial balance, right, you need to set. So you will call this set method, you will call this set method. So this set balance method was called, and you are now printing your updated balance. You are printing the updated balance. So this was the logic for depositing money is just like initial balance plus the amount you are depositing. So this is the only this piece of code is basically like the crux of the code, Rest is like just setting the balance, like calling our fetch method and set methods. So now what we are doing is I am creating an object of the account class. So our account got created. Let's say a new account is created. John has a new account in some bank where he has like 12345 as the account number and $1,000 as the balance. Now what we want to do, we want to create multiple threads to perform this operation. Let's say we want to create 3 threads. So I'm creating a transaction class which is basically using our account object because we want to perform this operation on the account. So I have created a parameterized constructor of this account class and I'm initializing this data member. And since this thread, uh, you already know that our thread class, wherever we want to, which class is basically used for multi-threading, that class needs to extend the thread class or implement the runnable interface. So I'm using this uh, extend thread approach, and now I want to provide the logic in this run method. So I'm overriding this run method and I'm calling the deposit method. I'm calling the deposit method. So let's say we are depositing $200. So what I am doing now, I am creating 3 threads: thread T1, thread T2, and thread T3. So what I'm doing, transaction T1 equal to new transaction, and when I do this, I basically need to pass the account here, right? Because in this parameterized constructor, this requires an account object reference. So I'm passing this particular object reference, and once like I'm done with the creation of 3 threads. I am starting the threads like T1 dot start, T2 dot start, and T3 dot start. And when we start the threads, you know that this run method is called. When I start the threads, the run method is called. So our deposit functionality will be also called once this run method has the logic of calling the deposit method, right? So it will call the deposit method. And what I want to do is I want to ensure that once one of the threads is executing, the other threads wait until the previous thread has completed the execution. So for that purpose, I'm doing a T1 dot join, T2 dot join, and T3 dot join. So this join method basically ensures that once one of the threads is working, the other threads will wait until this thread completes its execution, and you can get an interrupted exception in this case. So that is why we will handle it using our try catch block, and in the catch block we'll pass our interrupted exception object. So this is basically the example of a thread synchronization. This is like the classic example of thread synchronization, and this is easy to remember also, like the bank account scenario where you are depositing some amount, or you can also create some withdraw method and do the same. Withdrawing will be just some alteration in this logic where you will update the balance by balance minus amount. So that is like doing a uh, deduction from that initial balance. So this is about thread synchronization. Is it clear? Anyone has any questions? Okay. Okay. Okay, we have seen the synchronization topic. We'll see inter-thread communication. So what inter-thread communication is basically? So inter-thread communication is like communication between the threads. Suppose one thread is like uh, performing some task, and then there are like other threads waiting for this thread to complete its task. So what happens? You want to explicitly like notify the other thread that yeah, I am done with my work, you may please go ahead and resume your work. So what we want to do is we want to make some communication between these threads, and the communication between the threads can be made by wait and notify methods. So see, calling wait forces the current thread to wait until some other thread invokes notify or notify all on the same object. So let's say our thread T1 was currently processing some task. Thread T1 is currently processing some task. So what we want to do, we want to like pause this thread. So we are calling this wait method. We are calling this wait method. So what wait method will do? It will ask the thread T1 to pause for some time. It will ask the thread T1 to pause for some time. And what happens? There are some other threads. There are some other threads which want to like perform some job. So see this notify method for all threads waiting on the objects monitor by using any of the wait methods. The method notify notifies any one of them to wake up abruptly. The choice of exactly which thread is non-deterministic and depends upon the implementation. So some thread is now our thread T1 is like waiting or in a pause state. So let's say T2 thread is currently working and T2 thread has like completed its job. So T2 thread can basically do something like it can notify that I am done. So once this thread is notifying, so T1 thread will get a communication that okay, now I can resume because T2 thread has completed its operation. So in that case, the T1 thread which was in a waiting state will again come into picture and will resume its work. So this is the way how thread T1 and thread T2 are communicating. So this communication between the threads is basically called as intercommunication. So this is a example of intercommunication of threads. We can basically call it with the help of wait and notify methods. So see this example. This is a uh, this is an example where we are ordering some pizza, and see we have initialized a variable, a data member, where we have like made this like pizza arrived equal to false. So there is some there is a method like eat pizza, and then there is like a method called pizza guy. So see, we are providing some kind of like synchronization here, and we want to make this method as synchronized. So we have seen in the previous example, right, where we are basically using a synchronized block, or we can also like call synchronized on this method. So we are using synchronized block here, and we are checking while the pizza has arrived, we will wait. So what our current thread is doing, while the pizza has arrived, it will wait. And see, there is this pizza guy method. There is this pizza guy method. We will also provide synchronization over this particular method. So now when the pizza guy arrives, when the pizza guy arrives, we are making this value as true, that pizza guy has arrived, he will deliver that particular pizza, and we will like make this value as true. So let's say this dot pizza arrived is equal to true. Now our pizza guy has arrived, and our we are making this value as true, and here that people were waiting to eat pizza. So we will use the notify all method. We will use the notify all method to communicate to the threads that were waiting to eat pizza. So once this notify all is being called, so it will provide some communication to the threads who were waiting to eat the pizza. So now they will get a communication that pizza has arrived. So once they get the communication that pizza has arrived, so see this print statement system.println yum yum. So now that particular thread can go ahead and eat the pizza. So this is a example of this intercommunication. Did you understand this example? This is like very simple. We are using two uh, methods, that is like thread provides like wait and notify methods. So this is an example of inter-thread communication. Like until the pizza guy arrives, we will wait. Until the pizza guy arrives, we will wait to eat the pizza, and once the pizza guy arrives, that pizza guy will notify that your pizza has arrived, please go and eat your pizza. So in this eat pizza method, we are using wait method, and in the pizza guy method, we are basically using notify all. So notify all basically notifies the people who were waiting to eat pizza that pizza has arrived. So this is one of the examples of inter-thread communication. Any questions on this topic? Okay, we'll proceed with the next topic. Okay, see what is basically a deadlock. So deadlock is also one of the classic questions, like you might be asked the scenarios like what is a deadlock. So deadlock is such a situation when two threads try to access each other's monitor's result into a deadlock or a deadly embrace. So see, when there are like two threads, like thread X and thread Y, and they are trying to wait on the same resource, like they are trying to like access the same resource. So what can happen in that case is like none of them are like releasing the resource, means that can like cause some chaos. Or you can understand this scenario as well, like there is one thread T1 and there is one thread T2. Thread T1 is waiting for thread T2 to complete its execution. Means thread T1 is waiting for T2 to complete its execution, and then it will start resuming its job. And thread T2 is also doing the same thing. Thread T2 is like waiting on thread T1 to complete its execution, and then it will resume. So what is basically happening? T1 is dependent on T2 and T2 is dependent on T1. So in this case, T1 is dependent on T2 and T2 is also dependent on T1. So this is kind of a deadlock, right? None of the threads will complete its execution because each thread is like waiting on one another to complete its execution. So that will always cause a deadlock kind of a situation where this situation will never be resolved. Means if two threads are dependent on each other, so this situation is called a deadlock situation, and none of the threads will be able to resume the work. So see, neither thread will be able to run in order to acquire the object lock. So what we can do basically is like, see, see the second figure, thread X and thread Y. Now what we are doing, we are trying to use some synchronization method, and when we are basically synchronizing, what we'll do is one of the threads will first like lock the object, perform the operation, and the another thread another thread will be basically in a waiting state. And once the first thread has like completed its task, so what it will do, it will release the lock, and it will release the lock means it will give a signal for the other thread to go ahead and like perform the task. So the first thread will like give a signal to the second thread, and the second thread which was in the waiting state will now resume the work. So this is like handling the deadlock situation. This is handling the deadlock situation. So we should not create a scenario in which two threads are like dependent on each other, and like both the threads are trying to resume when the other threads are when the other thread like completes its execution. So that will like lead to a deadlock situation. So we can handle it using proper synchronization of threads, and we have already seen like how we can like synchronize the threads. We have seen in previous code, right, where we were able to synchronize it using a synchronized block or by using a synchronized keyword over that particular method. So that way we can resolve the deadlock situation. Okay. Now this was about the deadlock situation. You should basically use proper synchronization of threads such that there is no deadlock situation, and you can like use those synchronized block or synchronized methods to resolve the deadlock. Now let's go over another topic. This is about concurrency in Java. So concurrency, what does concurrency means? Concurrency means basically parallelism. Parallelism means a lot of work going at a time. So see, Java package covers concurrency, multi-threading and parallelism on the Java platform. Concurrency is the ability to run several programs or multi-programs or applications in parallel. So it's about running a lot of programs in parallel at the same time. So this is about concurrency, and there are like lot of ways in which concurrency can be achieved. There are like lot of ways in which concurrency can be achieved. We will go about one of the frameworks. This is like executors and executor framework. So basically Java has provided us some library to make our work easier. See, in the examples that we saw as of now, we were using a lot of means our own logic. We have written like synchronized block, and we had written like inter-thread communication like wait and notify methods to wait on each other. So what Java does is Java provides some library which like simplifies our work. Means there are methods which will basically help us to do the job in a simpler manner. So this is done by executors and executor framework. This is like this library basically will help us to achieve parallelism or concurrency in Java. So see, the Java executor service is the interface which allows us to execute tasks on threads asynchronously. See, this executor framework is basically an interface, and it will help us to execute tasks on threads asynchronously. And this interface is present in concurrent package. So we had already seen this util package, right? So java.util package also had all your collection data structures, and but this java.util.concurrent. So concurrent is the sub package within util package. So concurrent package will basically contain the library for concurrency. So the executor service helps in maintaining a pool of threads and assigning them tasks. It also provides the facility to queue up tasks until there is a free thread available if the number of tasks is more than threads available. Let's understand this scenario. Say there are like 10 tasks to be done. There are basically, let's say, 10 tasks to be done, and you have like 5 threads. Let's say you have a swimming pool. Let's say we have a pool, or you consider like a swimming pool. In your pool there are like 5 threads. You have kept 5 threads, and each thread will be performing like one of the tasks. Let's say there are like 10 tasks to be done, and you have like 5 threads. So at a time 5 tasks can be done at the maximum. So what you're trying to do is, you whichever thread in the pool is like free, that can be picked by the thread scheduler and assigned to do a particular task. So let's say one of the threads is assigned from the pool, means the thread scheduler goes ahead and checks in the pool that is one of the threads, is any thread free. So if any thread is free, it will be picked and it will be assigned a job to do. And once that job is done, it will be that particular thread will be again sent back to the pool. And again, if there are like more tasks to be done, the thread scheduler will again go and see if there are like threads available. Let's say like 3 threads are available, so those 3 threads can be picked up to do the tasks. And once those tasks are again completed, those threads will again be sent back to the pool. So understand this, we have a pool of threads, and we have our thread scheduler, and we have some tasks to be done. So what thread scheduler does is, it goes into the pool, it sees whether which thread is free now. So if that thread is free, the thread scheduler picks up that thread and it assigns that particular thread to do some job. And once that job is done, the thread scheduler again sends that particular thread to the pool. So in this way, you are maintaining a lot of threads which are assigned to do jobs at the same time, and whichever threads are free can be chosen to do the tasks. So this is about achieving concurrency and multi-threading. Means this is like achieving parallelism. A lot of parallel work is going on by different threads which are free. So this is the scenario which is basically created by concurrency package. So we'll go ahead and see the example. So let's go ahead and try to see some code here. I'll create one package. I'll create one package like multithreading.concurrency, and let's close this classes. And how we can basically achieve concurrency. So we can achieve concurrency through executors and executor service. We'll see the example. So let's say I name this as executor service example, executor service demo. And what I will do, I'll create a main method, and in this main method what I'll do is I'll create and execute a service interface. See, this executor service, when I select this executor service, you can see the package, right? java.util.concurrent. So this is coming from this package, java.util.concurrent. So I have created this executor service interface, and this interface, we have to like provide some implementation also to this interface, right? Remember the way we were using our interfaces when we were using collections. So it was like list interface and then some reference and its implementation by provided by some class like array list or linked list or something else. So here executor service is our interface, and then some class has to provide the implementation. So we have executors class, executors class in java.util package, and this executors class also is in the java.util.concurrent package. So this class has some methods. This class has some methods, and we'll see how we can create a pool of threads. So we want to create a pool of threads which can be like assigned to do some jobs, right? So what we'll do, we'll select this method, we'll create this method like new fixed thread pool, and let's say I want to create a pool of 10 threads. I want to create a pool of 10 threads. So I'll provide the value here like 10, and then what I will do is I have to basically create a runnable interface. So okay, what we can do here is I can use this, sorry, ex dot execute. There is one execute method and there is one execute method. So what we'll basically do, we'll create one anonymous class here. See, when I write this new runnable, right, it will create some anonymous class, and in this anonymous class you already have to provide whenever, just see this, this is like creating an anonymous class. So this execute method basically requires your runnable, it requires one instance of the runnable interface. So we will create this runnable interface, and when you do something like this, you have to provide the definition here. You have to provide the method implementation or your logic, whatever you want to basically do. So let's say I want to print out something like execute a service, and what I want to do after this is once this thread has completed the task, I want to shut down the threads. Let's say all the tasks are completed and all this pool of threads are free now. Now what we want to do is we want to like release the threads. So what we want to do is we want to shut down all the threads. So the pool of threads which was created, we want to shut it down. So see, we just have like one task here, and our task is to just print execute a service. So what we are doing is we are creating a pool of threads. Let's say this is creation of pool of threads, pool of let's say 10 threads, and this thread can be made to work. So when we do this ex dot execute, when we do this ex dot execute, right, so at that time it will expect a runnable interface object. So we pass that particular object, and then we have to implement this run method. So when we implement this run method, we have some tasks that the run method has to perform. So that particular logic which we want to like perform is in this run method. And what we basically do is once all the threads have been put to rest, means there is no task available to be done now. So at that particular time, what you want to do, you want to terminate these threads. You want to like free up your pool space. That is why you will do this ex dot shutdown. Now let's say in this example, I also want to print out something like for int I is equal to 0, I less than equal to 10, I plus plus. And what I will do is I'll print out I, and I will also print out something like this, thread dot current thread dot get name. And let me try to execute this now. See, what we're seeing is, see, at this time what was done is we are able to print from 0 to 10. And like what thread scheduler did was, thread scheduler saw that in our pool basically we have 10 threads. So it went ahead and picked one of the threads like thread 1, and thread 1 was picked, and it's now being asked to do this particular job. So thread T1 is basically asked to do some job, and it goes ahead and tries to print from 1 to 10, and we are able to print thread.currentThread.getName. So this is a simple example of using. Okay, yeah, we can do something like, yeah. So see, this hello will also be printed because apart from all these threads, right, there is one main thread. That main thread is basically the thread of the main method. So even if you don't create anything, there is one default thread of the main method. So that will always work. So see what happens after this ex dot shutdown, these 10 threads that we created are put to rest. Means ex dot shutdown like terminates the threads, and after the threads are terminated, when you want to print out something, it is being printed by your main method thread. It is being printed by your main method thread. So this is like, this is one example which you can use while you are like using real-time projects. So those the previous scenarios which we saw, those can also be used, but this is like a library that Java provides you. This simplifies your work and you need to like write less code. You can create just a fixed thread pool, and you can provide the number of threads, and you can use the execute method to run the task. And once that particular task is run, you can basically terminate the threads. You can do it by ex dot shutdown method. And this is like creating a pool of threads and asking your thread scheduler to perform some particular task. Let's go over another slide. Okay, we have seen this example, and see, we have like different methods of instantiating executor service. So there was one example that we saw where we were using a fixed thread pool. Now if we want, see, we can use Java executor service to create a single thread, a pool of threads, or a scheduled pool of threads. The executors class provides factory methods to instantiate an executor service as follows. So we have seen the second example, right? See, what we did was we created an executor service interface instance, and we created a new fixed thread pool. And after that, what we did, we provided 10 as the number of argument. So a pool of 10 threads was created. This we have already seen. But let's say if we want to create a pool which is having just a one thread, so you can use the first option, like executors dot new single thread executor. If you call this particular method new single thread executor, it will create just a object having a single thread. And let's see the third example. This is about creating a scheduled thread pools executor with 10 threads. In scheduled thread pool, we can schedule tasks of the threads. There are some methods by which you can basically go ahead and schedule some threads by time duration or something. So if you want just a single thread, then what you can do, you can use this executors dot new single thread executor. If you want like 10 threads, you can 10 threads or 20 threads or anything, you can use this execute start new fixed thread pool. This is like the most popular one. This fixed thread pool is basically the most popular one which is being used in thread pool creation. So let's go to our IDE. See, here you have like created execute a service instance. So let's say you can do something like this as well. Execute a start new single thread executor. When I do something like single thread executor, you don't have to pass any argument, because by default it will create a single thread. It will create a pool of a single thread, and here we had a pool of 10 threads. So that is why we pass the argument as number of n threads, right? N threads, you see, n threads is basically the number of threads. So this is like using the executor service executors and executor service package, or the concurrent package. You can say, you can how you want to do this job, you want to basically do it with the concurrent package. So this is how concurrency in Java can be achieved, like parallelism or multi-threading can be achieved by using this executor or executor or the concurrent packages. So concurrent package helps us to achieve parallelism or concurrency in Java. So this is like one of the ways. There are like multiple ways as well. And when we like create real-time projects, right? So at that time you will see that there are like things are like much easier. When you will study about Spring Boot, then you will see that there are like simple properties to be updated to just like allow your thread execution. Means you can just write down some property file, and with the help of the property file you can like specify how many number of threads you want to create, and how many number of threads you want to keep in waiting state or idle state. So there are like a lot of there are like lot of ways. And when you study about Spring Boot, you don't even have to write this much code to instantiate and create the threads. But interviewers might ask you to like create an example of execute a framework. So how you can like create an example from this concurrency, how you can like achieve concurrency. So if you want to achieve concurrency, you can like give the example of this one, this execute a service. So this is one of the ways in which concurrency can be achieved. So we had seen a lot of things, right? So synchronization was another topic which was like very important, and concurrency is also other topic which is very important. Other interview question is also like, if you want to, how many ways are there in which threads can be created. So one is by extending the thread class, and another is by implementing the run interface. So in either of the ways, you will have to provide the implementation of the run method. So this was about threads and multi-threading. So we had seen a lot of topics in multi-threading, and I'll pause for today. This was about multi-threading. We'll start another module tomorrow. So if you have any questions, you can ask, or we'll conclude the call today. Yeah. Okay. Thank you, everyone.